So let's move to the next part. Our next paper is on development of an ANN integrated streamlit web app for estimating soil compaction beneath agricultural tire by Rajesh Yadav.
20, na? Sorry.
Paper number 20.
Updated, no? Okay, yes.
You'll get 8 minutes. You'll hear a buzzer at 8 minutes and then 2 minutes more. Thank you.
Very good afternoon, everyone. I'm Rajesh Yadav, research scholar in Agricultural and Food Engineering Department, IIT Kharagpur. I'm going to present a seminar, this conference paper on development of an ANN integrated streamlit web app for estimating soil compaction beneath agricultural tire. Coming over the introduction part, the passes of heavy agricultural machinery cause the soil compaction, and due to the soil compaction, porosity of the soil gets reduced, and the oxygen content and moisture content of the soil supply to the micronutrients gets reduced. That's why the plant growth also gets reduced, and the productivity also gets reduced. So the soil compaction beneath the agricultural tire is more severe and persists for the longer duration or even permanently. So the factors which are affecting the soil compaction are wheel load, inflation pressure, drawbar pull, soil condition, tire size, wheel slip, and number of passes of tire. So by keeping these points, this study proposes with these following objectives: to develop and validate an ANN model for estimating soil compaction with the operation of a powered bi-splice tire in different soil condition, and second is to deploy this developed model using the streamlit web application. So coming over the materials methods part, this is the experimental facility which is available at IIT Kharagpur. This consists of a single wheel tester, a soil processing trolley, a soil bin, a drum type drawbar loading device, and weighing platform. This here we can vary the 4 conditions. We can vary the normal load on the tire, we can vary the inflation pressure of the tire, here we can vary the soil conditions as per the suggested by the ASAB, soft soil, medium soil, and hard soil. So here to increase or decrease the weight on the wheel, we used the dead weight, and this single wheel tester has been powered with the help of the 10 HP induction motors, and there are gear and chain sprocket mechanism to reduce the speed of the motor and increase the torque available at the wheel axle. And the single wheel soil processing trolley consists of 3 units. First is the rotavator to loose the soil, second is the leveler to level the soil at the same level, and third is the hydraulically operated compactor. So to get the desired compaction level of the soil, we use different hydraulic pressures on this compactor. To measure the con index value, to measure the soil strength or con index value of the soil, we use the standard con penetrometer, and this is the setup which consists of a S-type load cell, a standard con penetrometer, hydraulic cylinder, and potentiometer. So these are the images which shows the before test and after test. So before test we measure this con index value, and after the test, and the difference between before and after divided by before gives the level of soil compaction in percentage. This is the experimental plan where we vary the pull until we get the wheel slip 25%. We varied the inflation pressure from 12 psi to 20 psi, and the wheel load 1000 kg and 1400 kg. We varied the soil condition as per the suggested by ASAB, soft soil, medium soil, and hard soil, and their respective con index values are given here. We conducted the experiments with the help of 13.628 bi-splice tire, and the dependent parameters were con index value after passes of the tire and the level of compaction. So after collecting all the data, we developed an ANN model which had the 5 input parameters: pull, inflation pressure, soil condition, con index value before passes of the tire, and the wheel load. And the hidden layer consists of here two hidden layers were used. First hidden layer consists of 8 number of neurons, and the second layer consists of 6 number of neurons. The rectilinear activation function were used in the hidden layer 1, and in hidden layer 2 we used the linear functions. The optimizer which was used was Adam optimizer with the learning rate of 0.01. So this is the flowchart which was used to develop the Streamlit web integrated with the ANN model. We collected total 303 data points, and then standardized and transformed that original data into the suitable format for the model, and we splitted the data set into the training and testing in the ratio of 80:20 ratio, where 242 data were used for training and 61 data were used for testing. And we defined the search space of the ANN model, and they optimized the parameters of model with the help of the grid search CV method. So after developing the model, we saved the model and pickle files of input variable, and we deployed these two saved files in the Streamlit web app, and where user had to feed the input parameters, and he will get the con index value after passage of the tire and level of soil compaction. These are the parameters which were used for the performance evaluation of this ANN model. And this is the interface which I will explain later. These are the results and discussion. This is the variation of the soil compaction at different values of the pull and inflation pressure in different soil conditions, such as soft soil condition, medium soil condition, and hard soil condition. From this we can conclude that the soil compaction increases with the increase in the pull and the inflation pressure. The possible reason of this could be that if the inflation pressure increases, the contact area of tire gets reduced, so the ground pressure increases, and the tire sinkage also gets increases. This tire sinkage causes the higher soil compaction. The effect of the wheel load on the soil compaction in different soil conditions also can be seen in this figure, and from this figure we got to know that soft soil condition had the highest soil compaction at the 1400 kg normal load. As we increase the normal load, the compaction also gets increased because the void ratio between the soil particles gets reduced. This is the correlation heat map which shows the strong correlation with the pull of the the pull had the highest correlation coefficient with the con index value after passage of the tire, followed by the con index before passage of the tires, soil condition, wheel load, and inflation pressure. These are the train test errors while training the model, and the error was reduced initially for around 170 epochs. After that, it becomes almost constant. These are the scattered plot at the training and testing stage. We got the R square around 0.95 at the training stage and 0.936 at testing stage. And the other parameters are also given in this table. This developed model was deployed in the Streamlit web app, where user has to enter these input parameters, and he has to just click on this evaluate button, and he'll get the results like con index value after passage of the tire and the soil compaction level, how much soil compaction gets increased due to this. Coming over the conclusion part, the drawbar pull had the highest correlation with the con index value after passage of the tire among all the input features, such as soil condition, con index value before passage of the tire. And this ANN model 5861 architecture was used for estimating the soil compaction with the 13.628 by splice tire in different operating condition and the different soil condition. This web app had the highest correlation coefficient 0.934, and the developed web app had the can be used for choosing the operating parameters in different soil conditions and can be used to reduce the soil compaction. These are the references.
Thank you very much. Any question? Comments?